Hi everybody, welcome to the Manifold channel. Today we're going to do a follow-on to our Rendering Shootout, the video that showed how much faster Manifold is at rendering many objects than ArcGIS Pro or QGIS, which we'll call Q in this video. And what we've got here, we're looking at Manifold Release 9. You can do all this in the free Manifold viewer as well. And what we have here is a map that's connected, that shows layers from native layers that are within the Manifold project. And you can see in the project pane here that it has native US roads, and it also has what are called native shapes. That's a collection of 49 shape files. And the map has the layers currently turned off, so what we're going to do is we're going to turn the layers back on. And let's start by looking at native US roads. Let's see how fast Manifold can render 22 million roads in the United States. This is all the roads in the lower 48 United States from the GDT database for 1999. And as you can see, it renders them very quickly. We're doing this on a slow machine. Because some people are saying that, oh, that machine you used for the Rendering Shootout video was a real fast machine. So how fast is this on a plain garden variety machine? And let's control-click on that layer tab to zoom to fit. As you can see, it renders 22 million roads rather quickly. This particular machine that we're working on here is an AMD 8-core machine, but it's running on an ordinary disk drive. It's not running SSD at all. So this is a cheapo setup. And as you can see, Manifold is plenty usable. We can zoom in anywhere we want, like for example here to Los Angeles. And as you can see, it's slow enough that you can see that Manifold is not just pulling stuff from cache. It's actually rendering this stuff on the fly. It's actually pulling these objects out of the database. And this is running native. Now, why are we doing the shootout the way we're doing now? We're doing this here because people were complaining that the prior shootout, some people did, were complaining that, well, you compared Manifold native storage with ArcGIS Pro native storage using a geodatabase and Q native storage using GPKG. And everybody knows that Arc and Q are really slow when you use their native storage. You should have compared Manifold running to, say, with running against Q, with Q running PostgIS storage, Postgres, and running a database. Now, the whole point of comparing three desktop packages, of course, is to see how fast they run in native formats. But hey, if people want to see how fast all this stuff runs in Postgres, well, we're happy to do that too. Let's double click this to turn that layer off. Here's another layer which shows native shapes. This is 49 different map layers that are all grouped together, so we can turn them all on and off at the same time. And let's turn that on. And what Manifold is going to do now is it's going to reach out and it's going to grab out of these 49 different layers and start rendering them on screen. And it can do that pretty quickly. Now, there's two other layers that we have here. People that know Postgres know that something that starts with the public is probably a Postgres database, and they're right. What we have is two other layers here, which are pulled, the same things pulled from stored in the Postgres spatial database. And what we have is all the roads in the United States, the layer of 22 million of them, and then we have all the shapefiles. Here we are. I've opened that up. All the shapes that are stored in Postgres as well. We just loaded them right up into Postgres. So let's turn off. This is native Manifold storage. Let's see how fast the shapefiles are in Postgres. And what Manifold does is it'll start pulling from Postgres, and it'll start. It pulls data from Postgres, and it kind of using a batch because that's more efficient. And it'll start writing those in. This data, as you're seeing here, being rendered, is coming in from Postgres. And there's nothing faster at pulling stuff out of Postgres and showing it on screen than Manifold. And this is as fast as it goes. And what we're really doing is we're seeing how fast Postgres is as a database, as a spatial database, being able to fetch those objects and being able to display them to us 22 million objects. Manifold is pulling it from parallel. It's using multiple cores. It's doing all those tricks. But this is about as fast as Postgres gets, and that's because it's a general purpose database. It's a very fast database, but this is as fast as it is. And you can see that's taking considerably longer than Manifold running native. I wanted to do this comparison so you can see that now when we switch to QGIS, to Q, that we're using identically the same Postgres relational database. It's the same storage, and Q is pulling all that, pulling that as well. I'm going to turn that off because, as you can see, that's considerably slower than what Manifold can do. Let's turn that layer off, and it's still pulling data in from Postgres, so it's going to take it a while to think about that. So let's turn on, there we go, Postgres has released it. Let's turn the native shapes, and you can see how fast Manifold does its native shapes. You can see it's pulling out of native storage a lot faster than it can pull out of Postgres. And in the time that it took Postgres to do, say what, about a fourth of the states, Manifold did all the states, using native storage. All right, let's see how fast Q can go. So this is Q. Q doesn't really have any native storage, so what we've brought in here is this is a group that shows all those 49 shapes, the shape files, and this is the entire U.S. roads table, which is 22 million. Q is really good at pulling stuff out of Postgres, so let's see how fast it does. I mean, after all, the reason Q was created was to be a viewer for our spatial data in Postgres, so it does that pretty quickly. Let's see if we can encourage, let's zoom to group. There we go. And as you can see, Q isn't bad at pulling stuff out of Postgres. But this is as fast as it gets, with Q. It doesn't get any faster than this. And if you time how fast Manifold can pull stuff out of Postgres, Manifold will pull stuff out of Postgres, anywhere from 2 to 4 times faster than a Q. So let's let that cook for a while. If you like, let's go back here to Manifold. Let's turn off the native Manifold layer. Let's pull in the shapes layer for Manifold, which is the equivalent of what Q is doing in the background. Manifold uses slightly different strategies than Q in terms of pulling stuff out of Postgres. Like I say, it'll batch up slightly what it's pulling out of Postgres. So it tends to start off a little bit slower, but then it fills in faster. Let's go back to Q and see how fast Q is going. Okay, you can see that's about where Q is doing. If you note, by the way, Q is not reprojecting on the fly here. Q is just showing everything in lat long projection. Manifold is actually reprojecting on the fly because this map that we're looking at is a pseudo-Mercator projection coordinate system because we have a Bing Street Map layer that we're using as a background. I've turned off the Bing Street Map layer, so there's no delay from pulling tiles from Bing, and we're just we're making this a direct apples-to-apples comparison. So here's Manifold's pulling in stuff from from Postgres, and here's Q pulling stuff in from Postgres. You can see that even though we started Manifold later than Q, Manifold is kind of about even, and now it's going to start pulling slightly ahead. Like I say, Manifold is going to end up doing this on this particular machine, this particular data set. Manifold will pull the data out of Postgres about twice as fast as Q, maybe 3 times as fast. Now, both Manifold and both Q, because of the nature of Postgres, will be a lot faster if you zoom in to some region. For example, if we were to zoom in here to LA or to New York or some other high density place, you'd see that it's pretty quick in terms of how it populates. Okay, here's Q going. Q's still doing it. Part of the moral of the story is, if there's anybody watching this hasn't realized it yet, is that if you compare people that tell you that say, well, okay, Q may be too slow to work with very large objects, but it gets fast enough to be usable if you put the data into a Postgres database. Well, that's just not true. Because you can see this is pretty slow to kind of get all that stuff in. Here's Manifold again pulling all that stuff as well. And Postgres, of course, is a multi-user database, so whatever we're pulling out of this both sessions at the same time, that's fair. It's still an apples-to-apples comparison. There, Manifold's basically done, and let's see how Q's basically done too. Okay, we started Manifold later; it's still finished about the same time. Let's zoom in here to say LA, and you can see Q is not bad at getting the stuff from LA. Let's zoom in here even further. And as long as you can keep the number of objects on screen down relatively small, Q is perfectly usable. I mean, it's just not a problem. And likewise, Manifold. And that's really let's go back here. Let's go to LA and Manifold. Let's zoom into the same region. And let's zoom farther in. Say around there. I guess downtown LA is right around here somewhere. As long as you can keep the number of objects that you're fetching from Postgres, Postgres is a perfectly good data store. I don't want anybody to think, by the way, that I have a problem with Postgres, because Postgres is just a wonderful database. And Manifold, I think it's Manifold Engineering's favorite database. If you talk to people in Manifold Engineering, they really like it in terms of a combination for all the different things that it does. But one problem that it does have is that is when you've got to pull a lot of objects in terms of spatial work out of Postgres, it's not as fast as Manifold data storage, native data storage. In fact, it's considerably slower than Manifold data storage. So let's actually just turn off that layer, and let's zoom to fit here. Manifold data storage. Oh, I got to turn the layer on too. And you can see how quickly Manifold fills that hole in, fills that in using 49 different shapefiles. In fact, we can go all around the world here with Manifold while Q is still filling that stuff in. So Q is pulling the stuff in from Postgres, and here's Manifold native storage. Let's control click that to zoom to fit, and you can see it just works instantly. I mean, there's absolutely no delay whatsoever. So I hope you've enjoyed this quick video. The moral of the video isn't to beat anybody up about anything. It's just to discuss the different, what different packages do well, and where some packages are faster than others. There's nothing faster than Manifold's native storage, even if you're working with something like QGIS, which was designed to be a viewer for Postgres. It just takes longer to get all that stuff in Postgres. And one of the reasons is Postgres is basically a general purpose database. That it's good for spatial work is a testimonial to how incredibly well written PostgreSQL is. But it's not as fast as something which is a fully parallel system like Manifold. Let's again turn this on and off so you can see how fast it redraws. It's not as fast as something like Manifold, which is 100% parallel CPU parallel, which can reach into native storage and display that very rapidly without any of the hassles necessary to install and operate a large enterprise class database like PostgreSQL plus with the PostGIS add-on. I hope you've enjoyed this video. Thanks for watching, and goodbye from Manifold Land. Well, that was fun. If you want to see more, visit us at www.manifold.net. As always, Manifold delivers the world's most advanced, highest quality spatial products for GIS and DBMS at a low price that you can afford. Once again, that's manifold.net. See you soon.